Hello everyone, welcome to Schneider Electric PLC training tutorials where you will learn Schneider Electric PLC programming. In this lesson, we are going to cover the hardware overview of the Modicon M340 PLC CPU. So to assemble the unit to be ready for your PLC development, there are certain components that you might need to set up the hardware. So first we have the power supply unit. So in an earlier tutorial, we have already explained the different functionality of the different components that are found in this system. So the power supply unit is there to convert the AC main to a form that is suitable for our PLC, for our processor. So our processor sits just next to the power supply unit. Next to the processor, we have the digital input module, which is a 16-pin input module and works on a 24-volt DC and is of sync type. On our side, we have covered what sync sensors are and how to wire them. You can visit the site to get an understanding on how to wire a PNP sensor and NPN sensor to a PLC unit. Next, we have a digital relay module, which is our output, the DRA1605. So it's a 16-pin relay module. Then we have the rack, which is an 8-slot rack. So this rack is responsible for assembling all our components together. Then we have the 16-pin removable spring terminal block connections. So these connections are essential to transfer logic to our PLC through input module or to download logic for our PLC to our output devices through the output module. Okay. Alright, and then finally we have the input-output interface, the ABE7 input-output interface simulator. So you use this when you're trying to simulate your industrial process. So you can use it to test the logic of your program if it's behaving as programmed. Okay, so now these are the different components that we will need to make the assembly. So we have our terminal block for our input module. So we connect it in this port, and here we have these screw terminals. So these are the terminals which we use to fasten the block to the input module. And similarly, we have the terminal block for the output module, which we can also fasten it through these ports. Now, so this is a power module which has been completely dismantled from the system. Remember that the power module converts the AC main to a form which our PLC will be able to operate upon. And it is important to note that the power unit has a 24-volt output. This 24-volt output, we can use it to power our input module or to power our sensors, since most of our sensors work on a 24-volt DC power supply. So the power module occupies the first slot of the rack. So this is our rack when nothing has been mounted to it. The power module occupies the first portion of the rack, and the second portion of the rack, which is a position 0, is where our processor goes into. Okay, and the other slots now can be filled with our input module, output module, or communication modules. And the last terminal, the last slot of the rack used for expansion. So we may want to hang more I/O or communication modules. We have to expand it through the rack. Okay, so if you take a critical look at the rack, you will see some labels. Okay, the CPS stands for the slots where the power unit sits. Okay, the slot 0 is for our processor. Slot 1 and 2 and so on can be for different modules. So this is our processor. So our processor is the P34 2020 processor, and the version number is the version 2.6, and it consumes up to 2.33 watts. Okay, so this information, you can get detail about this processor and other related processors for the M CPU series on the setup manual. So you can download the setup manual, and there you'll get all the technical information that you can use. Okay, So they are really simple to understand, they are really simple to deal with. Alright, so now back to the processor. We are going to start first with the panel. So the panel have different display LEDs which display the different states of the processor. You can get all that from the documentation on the document I just showed earlier. And then we have a MAC address. So this is a MAC address of this processor and it's unique to this processor. Then the next is a USB port. So we use this for communicating with our PC. So when we develop the logic in the software, we have to download that logic into the, we have to download that logic or transfer that logic into the processor. And we do that via this USB terminal. Then we have the Ethernet port. The Ethernet port, now we use it to integrate our PLC into an existing network, or we use it to set up a network, okay, which our PLC will use to communicate. So the green ring here indicates that it's an Ethernet port. All right, and to use this port effectively, we should properly configure the port. We should properly set the IP address for communication. In further tutorials, we are going to see how we are going to make use of this infrastructure. Next to it is the Modbus. So this is a Modbus. So the black ring indicates that it's a Modbus. And Modbus, we use this Modbus for peer-to-peer communication. So it's basically serial communication. We can use it to talk to drives, for example, okay, to share and exchange information between the processor and our drive, or VFDs, for example. And next is the memory card slot. So the blue ring here shows the memory card slots, and we are going to see the purpose of this unit. It is also important to mention that we can always get the version number on the label of the PLC. So like for this PLC, like for this CPU, it is found on the top of the CPU, the very top of the CPU. You can get the version, number, and this information is very, very important when you want to select the PLC in your programming environment. You have to select the version for compatibility issues. After removing the memory card cover, we are going to have access to this port, and on this port is where the memory card resides. And the memory card, by default, it is the BMX RMS 008MP. So this is the memory card that comes with every processor the first time you purchase it. Okay, and in this memory card, we are able to store our application, but we cannot store user files. We can only store application and web pages. If we want to make use of storing user files, then we need to move to more sophisticated memory cards. And these ones, you have to order them through an online store. So you can get them from the Schneider Electric store. So the BMX RMS 008MP has a user file storage of 8 megabytes, while the BMX RMS 128MP has a user file storage of 128 megabytes. So these storages, we can use them when we want to carry out an inventory of a process, maybe recording down some sequence of activities for external analysis. Then we're going to need an extra space to store those information. Next, the memory card slot is an LED, a green LED. So this LED can take one of 3 states. So it can be on, flashing, or off. So when it's on, it shows that the processor have access to it. When it's flashing, it means the processor is trying to access it, so it can be read or write operations. And when it's off, it means the memory card slot is empty, or the processor have no access to it. And you should note that only Schneider memory cards are compatible with the P34 series of processors. Okay, so how do we now fit in those different modules to our rail? Right. So first, to do that, we have to get the rail and the module. Then we nicely fit it into the slot, okay, in this manner. And fitting it in this manner will enable proper sitting of the module on that slot. And after that, we screw the terminal to the rail to make perfect contact. Before mounting or dismantling any module to and from a rail, always make sure that the system is not powered. This is for security purpose. After mounting all those components, we are going to realize this layout. We are going to realize this layout where we already have our power module mounted, our processor, our input module, and our output module. And now for simulation purpose, you may want to have this AB7 interface input output simulator. So you use this now to test your input or your output logic. You can get the wiring information and how to use it online. So there are tons of information on how to wire and use this module online. All right. Next, we will now connect the input module to the connection port and the output module to the connection port of the interface simulator module. And doing this, we are going to arrive at this entire configuration. And with this configuration, you are now ready to start testing. Okay, but you should, however, note that this module works only on 24 volts DC. So we can mostly use it, so we can use it only for 24 volt application. All right. And since our relay output module can operate both in DC and AC, we can only use it when we are dealing with DC outputs. If we are dealing with AC outputs, then we should look for another simulator module. Now, with this arrangement, all we need to just do is to slot in our USB cable and connect the other terminal to our PC and start the programming. That will be it for this video. And please visit our site at www.expertlearningzone.com to get more detailed access to some of the explicit engineering concepts you will need for this training. And if you find this video helpful, please like, share, and subscribe. Thank you very much for watching, and see you in the next video.